Okay, I think we're recording now. So if it's Saturday, it's Py-Lambdas. And now, Sarah, over to you.
All right. Thank you for having me, first of all. Super excited to talk to you all. I'm actually not sure where you all are located, so good morning, afternoon, evening, night, whatever is relevant to you. But yeah, I was really happy that y'all reached out and asked me to just come do sort of an informal AMA type chat. So basically, what I figure we can do is I'll tell you a little bit about me and Planet and what we do. Part of why I'm here is to try to convince you all to come to my hackathon that's going to be in a couple weeks so that you can hack on satellite data with me. It's free, but everybody has to register just to make sure we don't have so many people. So I'm going to tell you a little bit about that and then give you a registration link so that you could sign up if you want to come. And then I'll tell you a little bit about some of our developer resources. So I'll start my background. Well, actually, let me go ahead and share this so that you don't have to stare at me the whole time. You can stare at some slides instead. All right, so you can see slides, right? I'm gonna assume yes.
Yes.
Great, so my background is I've spent about a decade at the intersection of software engineering and geography or geospatial science, GIS, all these different things. I am a Pythonista at heart. That is my language and tech stack of choice, so I'm really stoked to talk to a Python user group. It's been a while since I've gotten to talk to people who are near and dear to my heart. But I work at Planet and I've been here about 3 years. And right now I head up our developer relations team, which is basically doing anything to make developer users and API users of Planet's platform and data have an easier time to try to make their experience as painless as possible. I don't have many slides, but I do have my contact info here and I'll have it again in a minute. I would love to hear from anyone if you've got questions. Also, I don't have a link to it directly, but if you're interested, we have a developer user program to give you sort of extended access to data for free if you're interested in hacking on it. So I'm happy to talk about that too. I do have this cool slide, which is Planet by the numbers, basically. This is just an overview of a lot of numbers relevant to what we do. This slide gets updated frequently because at Planet, we build a lot of satellites and we launch a lot of satellites. So these numbers go up pretty quickly. So this is the latest update of this slide that we made. So I think it's just like a couple weeks old. But for those of you that are unfamiliar, at Planet, we do build and launch satellites. We don't directly build the launch equipment. We don't build the rockets. We pay other people to build rockets and we just hitch a ride. But we do build tiny satellites and they're about the size of, I want to say like a large loaf of bread or maybe a small corgi. They're squat, rectangular. If you're familiar with CubeSats, they are a 3-unit CubeSat. We have about 150 of them in orbit at any given time. So we have the largest Earth observation constellation in the world. Somebody just asked me, SpaceX. Yes, they are somebody that we do pay to hitch a ride with. So SpaceX rockets have launched and will launch Planet satellites. In fact, corgis in space, yes. Actually, I have a great picture of a corgi as a size comparison, and I forgot to share it, but I'll try to find it later. Yeah, so we have about 150 in orbit at any given time, and the reason we have so many is the thing that we do at Planet is we take Earth observation data. So our satellites capture imagery of the whole Earth. And what we do that's special is we capture the entire Earth's landmass every single day. So every 24 hours, we refresh that data set and we add to our time stack. So we've got a really deep stack of data. Everywhere on the surface of Earth has been, we've been doing that daily capture since about mid-2017. So our time stack for the full planet is at least that deep, some locations even deeper. As you can imagine, that's a lot of data. So we kind of take big data to the extreme. Just the daily imagery captures, we downlink about 15 terabytes of new imagery every day to add to our archives. We have, this says 1,300 images for every point on the Earth's landmass. This number keeps going up like crazy, so I never know what the latest number is. But in addition to our daily global coverage, we also have a constellation of satellites that does higher resolution imagery. We don't have 150 of those. We have, I believe, 15 of those. But they'll take much higher resolution and they take imagery essentially on demand. So if somebody's like, hey, I want to see Austin, Texas, which is where I happen to be located, sometime this week between the hours of noon and 3 p.m., I just want to see what the traffic on the road looks like or something, then we can do that. So that adds to our stack of data. We have launched 395 satellites total. I told you we have about 150 in orbit at any given time, and the reason we have launched more than that is Planet does what we like to call agile aerospace. So basically we build and iterate very, very quickly, our hardware as well as our software. So if you're used to working like in an agile software company where you're constantly iterating, we're doing that, but with satellites. So we build small satellites because they're cheap relative to traditional satellite industry, and we also build small satellites because we can build a lot of them pretty quickly. So we build and launch satellites, we update and iterate on our hardware, and so we've launched over 395 satellites so far. That's 27 successful launches. I believe there are 2 unsuccessful launches. One of them was just recently, I can't remember what it was. But yeah, 2 rockets that blew up on the launch pad, lost all our satellites, that's sad, but 27 that didn't. So that's sort of my whirlwind tour of Planet. I'm gonna check if there are questions in the Slido about Planet itself before I start bragging about my hackathon, which is what I'm really interested in. And feel free also to unmute and yell at me at any time. I can't see everyone's faces right now with my screen shared, so just interrupt me at any time.
Ay, otro nene.
What's that? I'm not sure if that's a question, but I appreciate the energy. Somebody in the slide who asks, what is Planet's tech stack? Good question. It's a little bit difficult to give you a single answer because we have a lot of different moving parts working together. But I think Python is probably our primary language used. Then we also have a number of newer components and APIs, platform pieces that are written in Golang. But when it comes to especially the satellite data processing, Python is definitely the language we're using there, just because if you're working with geospatial data and specifically Earth observation data, which is the type of data we call satellite images like this, all of the tooling for that data or that type of data already exists in Python. So you don't want to really go reinvent the wheels just to work with your data. So that means that we're all using Python every day. So most of our APIs that you're going to get Python platform access through are built in, Planet platform access are built in Python. But we do, like I said, have a couple Golang ones as well. Boy, there's a lot of questions. I don't know what order to go in, so I can start answering questions, or if you want to shout at me, that's cool. Otherwise, let's just go to the next one. Resources, tutorials, etc. have I used to learn Python and the libraries I use? I'm going to save that one because I'm going to talk to you about resources in a minute. Best part of working at Planet, I get to work at a space company that builds spacecraft, and that's pretty awesome. I never thought that as a geographer who writes Python, I'd get to work at a space company. So I love that they exist. Also, every time there's a rocket launch, the entire company gets together, watches it, and we eat pancakes. That's like our thing. So that's pretty sweet too. What do we do with all that data? That's a fun question. That's a good question too. So actually, does anybody here have a background or familiarity with geospatial data, Earth observation data, or am I, because I don't want to talk stuff you already know, but I want to explain it if you don't.
I think you're safe to explain it.
Cool. Awesome, because I like doing that. So when I was coming up in college, learning about what Earth observation data is, all through most of my career until, let's say, a couple years ago, the idea of high temporal cadence data set like this, which is what we call something like the Planet's data set, where you're updating it very frequently. So the temporal cadence is very, very fast. That was completely like unknown. That did not exist. So the sort of science that we did, geospatial science, is predicated on data that is maybe a month apart at best, a couple years apart very frequently. So you're looking at static snapshots of the Earth at a single point in time. You're not doing something that takes advantage of a deep time stack. So the sort of things we can do now with this data, I'm going to talk in specifics in a minute, but what I'm trying to convey is it's incredibly exciting because it's a huge paradigm shift to the industry itself. So part of the answer to this question is we're still figuring it out. The industry itself is still figuring it out. That said, obviously one of the most accessible things to think about is doing what we call time series analysis. So you've got data that shows changes over time. The sort of things that you can measure with Earth observation vary. I'll talk about imagery in a second, but just think about having something measured over a specific place on the surface of the Earth and then being able to see how that changes on a daily basis over a period of years. So people are using our data in, for example, agriculture industries. This is a really big use case. You've got farmers with fields out there that are very large. This is not, 500 years ago where the farmer goes and walks his own field every day. It's hard to get a picture of the status of your crops, like the health of your crops, without the aid of something like, and they used to use like airplanes or drones. That's something that was over the last decade or so. But now we're able to take satellite imagery where you have this sort of like passive capture system. You don't have to go hire a drone or a plane pilot. And you've got that daily refresh of the data. And as a farmer, you could just take this, aggregate it, and do immediate analysis. So you can figure out like, hey, this field in the northwest corner needs more water than we've got it set on the automated watering system, because 2 days ago it looked better than it did today, for example. So agriculture is a huge use, but another use that I think is amazing is directly working towards climate change monitoring, awareness, and data collection. And this is a big thing that just started this past week. We're going to basically we have Mosaic Data, which is where we stitch together a global image that covers the whole Earth. We're going to make Mosaic Data of like tropical forest areas across the entire Earth. So it's basically this band across the middle section of the Earth, if you're looking at a map, available to people who are doing climate science and climate change tracking, so that they can see basically if the status of a forest is a really good indicator to the status of climate change effects in a particular area. So if a place is being deforested, sorry, it's a hard word, they can figure out how that affects or speeds up basically climate change. Somebody just asked, for agriculture or other customers, what is the pricing to access information like that? Excellent question. I have no idea. I'm sorry that I can't answer that. I don't work in sales, so I don't know, unfortunately, what pricing is like. The best I can do is connect you to people who can answer that question. I work on the dev side, so yeah, sounds pricey, but cool. I can't speak to, like I said, specifics at all, but relative to other image providers, well, first of all, nobody has that kind of imagery. We do a lot of, for example, if you're doing research work, academic research or development work, there's a lot of ways to get access to data for non-commercial purposes that are free or low cost. So if you're less interested in a commercial use case, then there are other ways to get data. Any questions on that before I go pick another one from the slide? Okay, I'm gonna go ahead and pop to the next slide so that I can talk a little bit about Planet Hack, and then I'll come back and talk more about Planet again in a minute, don't worry. So talking about getting access to data to do cool things with it, the hackathon that I'm running next month is a really great way to do that, and it's a great way to do that with 150 other people who are also interested in figuring out what you can do with the data. Basically, last year we started this idea of a public hackathon. It was on site last year in the Planet headquarters in San Francisco. This year, though, of course, we can't do that. So it's going to be all online on Zoom and Gitter. If you're familiar with Gitter, it's basically like Slack, but easier. And it's open to anybody in any time zone. It is going to be North American time zone focused, unfortunately, just because that's like where I live and there's only one of me. But we are going to try to do some things that makes it more globally accessible. So I would love to see more Python people attend this, even if you have no background in geospatial data, raster data, satellite data, Earth observation data. That's totally fine. Most of the people that show up to something like this don't. And part of our hackathon or hack experiences are learning what you can do with the data. Like any hackathon, you're not really going to get a full polished project done. That's not really the goal. The goal is to figure out what you might do or ask, what kind of questions you can ask, and then attempt to work on answering them. So I love promoting this partly because internal at Planet, we have this huge collective hackathon, hack culture. We have at least every 2 quarters, sometimes more frequently, a full week where the entire company has a hack week. So we all shut down non-essential stuff. I mean, we still have essential stuff going on. Like there's still satellites in orbit that need babysat and mission control, and occasionally launches happen. But we shut down as much as we can non-essential work, and the entire company gets together and works on hack projects across the company. So not just software engineers or, well, we have hardware engineers because we have satellite builders, but we even get people from what you not traditionally see attending a hackathon. So our sales team, our marketing team, product, that sort of thing. And it's really cool to see everybody come together and sort of get creative and experiment. Anyway, because of that culture, I'm really excited about our public hackathon because it takes the same feeling and spirit and makes it accessible to hundreds of other people. And I would love to see you guys show up. Thank you for listening to my spiel. Now let's get back to resources and talking about data. Somebody asked what resources tutorials have I used. Learning Python in general, what I do honestly is I point people at the official python.org docs because there's a really great get started with Python tutorial there. I think everybody here is probably familiar with at least some level of Python from what I understand. But if you're starting from absolute scratch and you've never touched it, I do recommend the official Python.org tutorial. It's pretty great actually. So that's what I used at the beginning. Also, I was lucky enough that my partner is a Python engineer, and I was coming from a different tech background, but he's like, you should really learn Python. So I had somebody in my house to sort of get me nudged into starting. But then finally, honestly, the best way to learn is just find a pain point in your life that you can solve with code, and then figure out how to solve it with Python. That's what I did. So I was working in GIS, like I said. I agree, by the way, with Mandy, who wrote in-house tutors are the best. It's true. It's really a spoiling thing. But what I did at the beginning was I was working in GIS, and there's a lot of repetitive data munging sort of work that I was doing using the traditional GIS software, and it just felt like it's a waste of effort. There has to be a better way, and the better way, of course, is Python, which everybody here probably knows. But just figuring out how to solve my actual day job use cases with Python and make my life a little less painful was what got me started down this long and winding road. So resources, if you're interested specifically in writing Python with planet Earth observation data, developers.planet.com is our dev center. So that's where all of the API docs and guides and everything related to using the API lives. If you go to that developers.planet.com site, there's going to be in the top navigation bar says, I believe there's resources, and then you click dev trial, but basically there's a developer trial program. And that's how you can get 90 days of data access to really kick the tires and see what you can do with the data. That's non-commercial, but it's for anything research, development, learning, etc. So if you want to play with data, definitely apply for that. If you want to mention that we're at this meetup in your application, that'll catch my eye, and I'll make sure I sign you up as fast as I can, which is probably going to be Monday because I'm not working today or tomorrow. On that developer center, there's a subsection called Planet School, which you can also get to at planet.com/school. And a lot of what my team does is we build tutorials and resources for sort of helping yourself along with whatever you might need to use Planet's platform or the type of data that we have. So a lot of this is like, if you're an engineer and you're familiar with code, but you've never worked with satellite data, what do I need to know? We've got some basic introduction stuff there. But then a lot of our users are coming from a background of like, I know data science, but I don't know web programming. How do I use an API? And we've got that there too. But then there's a lot of use case focused things. For example, using some open source GIS tools and how you can do specific things, learn to do specific things with satellite data. But probably most relevant to everyone's interests here is our notebooks repo on GitHub. It's just called Notebooks because we named it years ago. We probably should have given it a better name. But Notebooks is this massive collection of Jupyter notebooks that has everything from getting started with using Planet's APIs to doing deep dives into machine learning analysis of satellite data, time series stacks, that sort of thing. We've got gosh, I can't even think of how many. I want to say upwards of 100 notebooks in this repo, but I really haven't counted lately. But all of this is available. If you're familiar with Jupyter, you'll already be able to set it up yourself. But there is a Docker image that you can pull, so you don't have to build all of the geospatial Python libraries with it. So hopefully painless to set up, but if you have troubles, let me know, because some of the geospatial libraries are a little bit finicky. So if you're trying to set it up yourself instead of just pulling the Docker image, you could get stuck. And then finally, we have a Python client and command line interface that you can just pip install. It's on PyPI, and pip install Planet, which I think is the best package name ever. But that also lets you interact with our APIs and do it directly from a CLI tool. So let me catch up. I've got a couple questions. Oh yes, thank you to the person that posted the Planet School link in the chat. Somebody asks, what can a Lambda School grad do to stand out as a candidate at Planet? This is a good question. I've been interviewing interns lately, which is a little bit different probably than what you're asking about, but let me think a little bit regardless. So it's 2020 now, and we're all working remotely, whether temporarily or full-time. I think one thing that is important to show as a candidate is solid communication skills and the ability to be proactive in your communication. And I like to quote the Zen of Python, explicit's better than implicit, especially when it comes to working remotely. So somebody who shows that you're going to be very literate and conversant in remote working and communication, I think is important, and maybe not something you'd think of immediately if you're looking at like an engineering job posting or something. But also, if you have no background in geospatial data, Earth observation data, that's completely fine. Most candidates do not. However, if you take the time to maybe look at some of our notebooks, or maybe read one of our like 101 level tutorials and become at least a little bit familiar with some of the terms, that's actually going to put you quite a bit above a lot of candidates, just because that specific niche of data science is so uncommon that not many people are coming in with that. Somebody asked, does Planet allow people to work remotely? Yes, of course, right now, everybody is remote except for maybe half a dozen people who are building satellites in the physical office. But even before COVID times, I've been at Planet about 3 years and a week and a half. I just passed my 3-year anniversary. But I've been full-time remote the whole time. So I live in Austin, Texas. The headquarters is in San Francisco, but I've been working remotely that whole time. So yeah, we have, I want to say maybe 150 full-time remoters before COVID times, but don't really quote me on that. We do have a bunch of remote folks for sure.
Actually, I have a quick question. I'm
yeah,
sorry.
Go for it. Yes,
so I was
do.
looking at your website for careers, and so like there's not really a place for remote stuff. So do you just apply? Because there's one that's in Germany. So how does that work?
That's a really good question. That's a great question. On the career site, the best thing I can recommend is that you get in touch and apply anyway. The difference between the North American and Berlin, or the Germany-based ones, is going to be like where you're able to work or where you live, which side of the ocean you're on. But beyond that, like if you're in the US and you're interested in a posting that might say San Francisco, I encourage you to apply and ask anyway, just because everything is so strange right now with the COVID times. There's a good chance that some of the locations are listed with an office, but in reality it's remote. And then even before that, we do have a thing where it's like remote, on request or depending on circumstances. So I believe what they'll say is just apply anyway and then talk to the recruiter about it, because it's pretty flexible, but a lot of them won't explicitly be remote only. Lots of questions. Does anybody, I see people can vote on them. I just realized that. I was gonna say, does anybody have one to say what we do next? Cool. How much detail is visible in the images? Is there friction with governments? Good questions. So our imagery that we do the entire globe every 24 hours, that is called 3-meter resolution. So what that means is 3 meters on the surface of the Earth is 1 pixel in the image that you're looking at. So if you think about like a car, it's gonna be maybe a pixel or 2. A truck, semi-truck might be a couple more pixels than that. So it's not like you're going to read somebody's license plate in this imagery, but you're going to be able to see that a car is there. That said, is there friction with governments? No, not really. Definitely not that I'm aware of. In fact, a lot of our customers are going to be governments who are doing like scientific work or analysis, and they're able to use our data. But part of so Planet's mission statement is that we make the whole world visible, accessible, and actionable. And that means to everyone. So we don't sell only to governments, for example, or only to a certain slice of the industry. We make our data equally available. So because of that, there's no like favoritism that people can get upset about. So anybody can buy our data. What does Planet do with all that data? I think I talked about this a little bit. If you're talking about storing it, we put it on lots and lots and lots of servers. And let's see, there's an Elasticsearch in front of it for metadata organizing. Based on Planet's data, is the media understating or overstating how screwed we are? That's not a big question at all. I don't think I can answer that explicitly, but I think it's a good conversation starter. So let's talk about it. Are we talking about climate, for example, or something else? Nobody wants to get into it. That's fine.
What was the question again, Sarah? I apologize.
Oh, no, that's fine. The question is, based on Planet's data, is the media understating or overstating how screwed we are?
Oh, I definitely think they're understating major.
Expand on that, if you will.
I think, well, I mean, given the current Trump administration and especially America, we're so focused on the economy of it all and, you know, worried about people losing jobs that we're making that a priority over what is obvious, what science is showing us, that we are indeed experiencing climate change. We are indeed destroying our environmental resources, but people, it's uncomfortable to deal with that and have to say, hey, I have to give up some of my comforts in order to address this issue. And so right now, I feel like the governments are just kind of turning a blind eye to it, even though the data is obviously there.
I think when it comes to the media, there's not nearly enough stories on climate change. So the only way that you get coverage from the media is as an ancillary or a bolt-on, if you will, to another story, like the wildfires in California. They might mention, you know, that there are some people who believe that it's climate related instead of actually doing stories focused on, like, here is how, you know, the different land masses are changing because of climate, actually doing the stories on climate, you know, tracking. I feel like there's not enough emphasis placed on like tracking the polar ice cap and what's happening there. I just think there's not enough coverage specifically on the topic.
I like that point you make, and I agree that part of our problem is lack of coverage, and more than that, lack of visibility. If there's coverage of data, but you can't really see this effect and how it might relate to you, your planet, your area, it's harder to really personalize that and make it have an impact. So of course I'm biased, but I do think that this is a large thing that Earth observation data specifically can contribute to, which is making those changes on our planet visible. So if you talk about, you know, a polar ice cap melting or Arctic ice shelves are breaking, and this is, you know, things that have unprecedented, never happened before. You can read that and you think, yeah, that sounds like a big deal, but, you know, I've never been to the Arctic. I don't really know what that looks like, and it doesn't really feel directly relevant to me in my life. But when you can see an image where there's an ice shelf, and then 2 days later there isn't one, and you can directly see with your eyes what has changed over time and the sense of scale and the effect on the actual planet, it really makes something more real than just reading data could. And I think that's one of the biggest, most powerful uses of Earth observation data, is to make those things visible. So I mentioned making change visible, accessible, and actionable. I think the visible part is underappreciated, and I think that's part of the reason that our coverage is so low or non-existent in things, especially when it comes to planetary climate and the status of the environment. Being able, for example, to see here's a rainforest in Peru, and then 2 months later, here's the same rainforest, and you can see the swath that's been clear cut out of the center of it. Turns out there's illegal logging going on in here, but nobody on the ground is actually able to see it because it's so deeply in the center of this tropical rainforest where nobody is going and looking with their eyes. Being able to show that sort of thing with imagery that we otherwise wouldn't necessarily have exposure to, I think makes a huge difference in transforming like public conversations and media coverage.
Can you guys hear me okay?
Yep.
So I think there's two questions. One is about the US media being able to share that information. And last time I saw the media, I think they went from not like thinking that there was not enough data and stuff like that. And now they went through like, it's almost, you have to stop looking at the data and you really have to nitpick like certain things and like manipulate it in a way that is obvious that you have an interest, that you're making a lot of money or profit from it, and you just want to continue this dialogue like it's okay for us. And I think there's a second question that everybody was talking about, that how does we actually fix this, or how we actually do something about that. And this is a global problem, and there's not a global government. Like, we're the USA government. We're not gonna tell Peru how they're gonna do things. We're not gonna tell other countries what they should or should not do, even though there's consequences because they have their own sovereignty. There's dictators, there's republics, there's democracies. They do things different ways. But the best solution that I've seen is what Elon Musk has done with Tesla and the different technologies that he's coming with the cars and other things, that it just makes sense that you have a new way to do it that is cheaper, healthier for the economy, and it's just better in every other way to maintain and actually like give people livelihood when it comes to jobs and things like that. So I think that's a solution to come with. That's my 2 cents for that.
I love this question and would like to stay here, but I was scrolling and realized that there are a lot more, so I'm going to move on. But as always, feel free to interrupt me at any time if you all would like me to go back to something or add something to a previous one. But thanks everyone, by the way, who unmuted and talked. I thought that was really enjoyable. Let's see, what tools, libraries, and frameworks do you use to analyze all that imagery data? I love this question. Let me tell you about some of my favorite Python tools. Actually, I'm going to post a lot of links that I should have had already. So how many here are familiar with NumPy? I can't see your faces, unfortunately, so let's just unmute and yell at me if you are familiar.
Yes.
All right, we have at least a few. Cool. So if I'm talking about NumPy, for those of you that are not familiar, it's a great way of analyzing large sets of data. Everything is a number in NumPy. Everything is an array of numbers of one or more dimensions. So if you are familiar with working with NumPy, one of my favorite tools for working with raster data is essentially, it allows you to work with raster data as if it's another NumPy array. So if you're familiar with NumPy, you could use it with the satellite imagery data using this tool called Rasterio, which I will link to, which is basically a translator for that raster data into NumPy's paradigm. So if you're working with imagery data in Python, Rasterio is one of the main things you'll look at. A little bit higher level from that, there is a tool set called Gdal, G-D-A-L, I'll spell it. And I'll find a link for you in a minute on this. But Gdal is basically anything you could want to do with any kind of geospatial data. This is the library that you will get. So anything that is a more specific tool is probably a derivative of or a wrapper around some Gdal functionality. Gdal is just a C library that works with every kind of geospatial data you can imagine. So I use Gdal a lot. Rasterio is a Python interface to that Gdal. Yes, thank you. To that Gdal library. If you go to that Planet School website I mentioned previously, there's some getting started with Gdal tools. Those I believe focused on the command line interface to Gdal versus the Python interface. But if you look, we've also got Rasterio tutorials, which is that Python interface to the same tool. Libraries and frameworks. Let's see. So Gdal is the big one. You're also going to run into something called Shapely, and I will find this.
reposting the links somewhere?
It's a question for not me.
They are in the chat. If you look in the chat.
And what I can do is add all of these links to the slide deck, which I'm gonna send to Doc before or after we finish up, and that way you guys can have a clickable slide deck too.
Excellent. Then I can post it in the Discord.
So awesome. Perfect.
That's where you guys can find it if once Sarah sends it to me.
Perfect. Somebody asks what the most challenging project I've worked on at Planet is. I don't know how to characterize the most challenging. There have been things that are difficult and been things that are super rewarding, and I can't pick one. I will say honestly that growing a collection of developer resources that didn't used to exist is probably the most rewarding. It's sort of this overarching project. It's not a specific thing, but things like that Jupyter Notebook repo, tutorials, examples, that sort of thing, that definitely is the most rewarding, just because as a geospatial person who also writes code, I completely understand how high the barrier of entry to just working with this type of data is, and how inaccessible it can be, even if you have lots of experience in all different areas, lots of different skills and areas of expertise. So trying to break down those barriers and make working with this kind of data a little more accessible feels super rewarding, and also a bit challenging just because it's not a really common data type. It's not a really common type of data analysis. And also the little thing of, like I said, this high temporal cadence data set has never existed before, so the entire industry is kind of figuring out how to use it. Yeah, so that's rewarding. I wouldn't say it's necessarily challenging, but it's rewarding. Let's see. I answered if we work remotely, how much detail I answered. What do we do with all that data I kind of talked about? Do we not use OpenCV? There are actually some uses of OpenCV, actually, even if you go look in that notebooks repo. I don't know the details of how our CV folks, our computer vision people, do their work. They're probably using OpenCV over there. I just, everything they do is sort of in a magical black box that I have no insight into, just because it's far beyond my areas of expertise and domains of knowledge. But I know that there are examples in the notebooks repo where we're using OpenCV and Python to do feature extraction out of imagery, for example. Data stores and databases. So the raster data itself does not go into a database. We do mostly use, like I said, Elasticsearch for dealing with the metadata of it. But the raster data just lives on the hard disk somewhere in somebody's server all across the US. Most common tech stack of Planet's users. I know that I'm biased, but I do think Python is probably the most common tech stack if they're writing code with our data, just because, like I said, that's where the tooling exists. But I know that there are also a lot of people building web apps. So there's a lot of JavaScript users of something we call tile services at Planet, which is basically a service for map tiles. So if you go to Google Maps, for example, and you move the map around, that background is built out of map tiles. So we have tile services for Planet Imagery if somebody wants to build a web app with our imagery in the background. So there are people using JavaScript, of course, to do that. What's the best software team at Planet? I am biased because when I first started at Planet, I was helping build out what we call our data API, which is our search API basically for the entire archive of data. So I think that's the best team. However, all of the teams are great and I love them equally, of course. But data API, search API team has a special place in my heart. How did I meet Doc? That's a good question. I think you reached out to me on LinkedIn, is that right?
I did. I actually saw you at another event. I watched the recording, and when I heard about what you did, I reached out to you on LinkedIn and said, "Hey, I really like what I like your presentation, and we have this group, and would you?" And you said yes. So.
Yay. Yeah, I was trying to remember. I saw this question pop in front of my eyes a few minutes ago. I was like, how did that happen? But yeah, the LinkedIn message. So yes, to answer the next question, I am active on LinkedIn in that I have a profile, and every couple of weeks I go and check it and clear all the old messages. It's probably not the greatest way to get in touch with me, just because I'm not on it every day or even every week. But I do have a profile. If you want to connect, I'm a little bit weird in that I don't just add every connection, so I'd rather that it's somebody I actually interacted with. So just put a message in there saying like we met at this meetup event, and then I'm happy to connect. Is it unrealistic to pursue a position at Planet without a degree? Not at all. A lot of our engineers come from non-traditional backgrounds, or maybe they have a degree that's not related to the work at all. My degree actually is in geography. I don't have a degree in anything computer science related, anything developer or technical. I mean, geography is technical, but it's in a different way. And I've really enjoyed my time at Planet. But I told you a few minutes ago, I was interviewing for interns lately. And we're actually starting a new intern program specifically focused on non-traditional, non-university four-year degree type students. So I'm about to have a whole bunch of interns start on my team, and none of them have degrees or are pursuing traditional degrees. I think it's great, especially if you're coming from another background. Maybe you've been doing a different career for a while and you decided to switch careers. That's awesome. That means you bring an entire set of experience and domain of knowledge that maybe nobody else at Planet would have. So if you have interest in the sort of thing that the posting is about, so if you like writing Python code, building APIs, working on problems that involve incredibly huge amounts of data, or maybe machine learning and computer vision techniques, whatever you're interested in. If there's a posting that's relevant to your interests and you would like to learn more, definitely don't let degree status stop you. Does Planet package and sell imagery data as a service? Yeah, I touched on this a little bit with our tile services. I think that's probably what you're talking about. Basically where you can stream imagery into an app. If you're talking, if you're talking about getting imagery that's like that daily imagery, but frequent updated, yes, we have an API that allows you to subscribe to like a specific area on the surface of the planet, for example. And every time there's new images for that area that meet your search criteria, then you can get a notification, or you can even have that data pushed into like your cloud storage location, for example, automatically. So you can say like, here's my Amazon Web Services S3 bucket. Every time there is new imagery in Austin, Texas that has no more than 10% clouds in the imagery, dump it into my S3 bucket. You can do that. So if this question is referring to something else, let me know. I would be happy to answer it. Somebody asked, do you have to have a degree in science? I think I touched on this already. Sounds like your company is full of very smart people. Honestly, yes, it's amazing. And I should have mentioned this when I said it's one of the reasons I love working there. My very first day at lunch, I was sitting at a table in the main office's lunchroom, and just like all of the conversations I was hearing around me was blowing my mind. There's all these brilliant people. You can definitely feel a little bit intimidated by that, but it's also super exciting to get to talk to everybody. You don't have to have a degree in science at all, just to reiterate what I said already. There are a bunch of amazing people there with all different skills and abilities. I think the main thing is, curiosity and interest in the mission and what we're doing. What about deforestation? How does tracking help with that? Somebody asks that. I think, again, I touched on this a little bit, but basically being able to directly observe where the deforestation is happening in places where we wouldn't otherwise have the ability to do that observation is one of the major things you can do with data. Using Earth observation data to detect the status of vegetation on the surface of the planet is one of the, I don't want to say simplest, but it's one of the like core uses of this kind of data. So it's really relatively easy to throw a bunch of pixels of Earth observation imagery into a Python machine and munge it and extract where are the places where trees used to be and are not anymore. Where's the place where you have tree canopy? Where's the place where you have no tree canopy? That sort of thing. So that's one of the big uses of data in that area. Oh, more questions. Let me refresh. Can you describe the hiring process at Planet? I can talk a little bit to engineering specific process, which I think is probably what everyone on this call is asking. Of course, I have no idea how it works in other areas. So in general, all of our jobs are posted on planet.com/careers. Like I said previously, don't let the specific city location stop you too much from applying. Definitely encourage you to apply and reach out to a recruiter to find out if remote might be an option for that specific position. The only thing is, like I said, if we've got a Germany-based position and you're in the US and prefer to work in the US and you're not imminently planning on moving to Germany, you probably don't want to apply for a job over there, just because they're all going to be working while you're asleep. So planet.com/careers for the postings. Apply there. The first step is your application will go to one of our internal talent team folks for review. So they're going to reach out to you, have a casual phone call just to find out why you're interested in it, what you're interested in, maybe what your background is. After a recruiter, usually there's a couple different steps for our engineering teams. Oftentimes there will be some kind of take-home test assignment. So build a demo project related to what this team does. It's not going to be too heavy. You're not going to be doing like a week of labor. That's not what we want. It should be like a 4 hours or less type project, just so you have a chance to like show off the fact that you can do this kind of thing in general. But more importantly, for most of the interview teams, they're going to use that take-home test or take-home project during some interactive discussion calls, just so you can dig a little bit deeper into what you did and how you did it. I know a bunch of teams are moving away from like the traditional, like, let's do a whiteboard thing, especially now that everybody's remote, and you can't really learn much from that anyway. So, and I know I don't do whiteboard interviews myself. So a lot of how this is going to work with engineering teams is going to be more conversational, or maybe even like pairing over with like remote desktop or something, or, you know, share your screen sort of thing. Just like writing code the way you actually would write code, and talking to somebody the way you would actually talk to somebody who is a coworker, and not like somebody staring at you use a marker on a whiteboard, which I think is ridiculous. So there will be a take home. There will be probably a couple phone calls with maybe the hiring manager or somebody on the team. In the old days, we would have an on-site sort of half day of interviews. That's not happening anymore. So as far as I'm aware, it's all on Zoom. But it gives you a chance to talk to a lot of different people. You'll sort of rotate through a panel of folks, have a lot of like half-hour, 40-minute conversations. And then beyond that, I think next steps, if you were being hired, includes like another recruiter call and then the offer. Of course, that's going to vary, but that's the basic gist of how it works. Hope that answered the question, but let me know if it didn't. Somebody asked, what exactly is our mission statement? Looked online, but can't find. I will find that link and paste it at you in a second, but Planet's mission is to image the whole Earth every day and to make change visible, accessible, and actionable. That's the short one. The short TLDR of it. We talk about mission 1. If you're reading about Planet's like old press releases or something, you might see mission 1 mentioned. And that's what we called our initial goal of imaging the whole Earth every day. So it took us a couple of years to actually get to that point as a company. And we achieved that, like I said, I think it was mid-2017, maybe even November 2017. It was right around the time I started working at Planet, actually. So when we achieved mission 1, that's when we got the capability to image the entire Earth every day. And now everything we do is working towards making change visible, accessible, and actionable. Can I recommend an in-house recruiter to talk to about applying? Not a specific one, because they're going to be assigned to, like, the recruiter will be tied to the job posting depending on what team it's with. So it just depends on what area you're interested in applying to. Let's see, I hit the bottom of the list, but I'm going to go back up in case I missed any. Eavesdropping on extremely interesting conversations sounds like an amazing perk of working at Planet. It really is. I agree. It's one of the coolest things. So there's so many interesting people doing amazing things. I love how a bunch of people have come together, even though it's COVID times, nobody's in the office. They're still carrying forward these like discussions, social groups, interactions, remotely, like on Zoom. So we've got a couple different groups of folks that have been regularly doing book clubs, where we'll get together once a week or every 2 weeks to just discuss a new chapter in a book that we're reading. And I think it's really amazing the sort of people that would just want to do that in a workplace in the first place, and then keep it going even when you don't have that face-to-face contact. Let's see, package and data, I saw that. I believe I've hit all the questions. So if I missed any questions, go ahead and unmute and let me know.
Sarah, you didn't miss any questions, but since you brought up the company like hackathons, could you tell me more about that? Like, how long does it last? What are like some cool projects that came out of it? Do you like work sort of like within your normal teams, or do you try to go beyond the people that you normally work with? Can you just talk more about that?
Yeah, absolutely. Actually, let me stop sharing real quick. I'm going to try to pull up another slide deck related to the hack stuff so that you could stare at something else while I talk to you. My computer is being slow. I need elevator music while my computer switches tabs or something.
Well, I'm just really intrigued by like an internal company hackathon, because it sounds like, you know, a great way to work with people that you don't always get a chance to. It sounds like a lot of fun.
It is,
and
I
it seems
am,
like there might be some really cool projects that would come out of it too.
There are, and not, so like I said, most hackathons, of course, you're not going to finish a full project during the hack week, hackathon, hack event. But some of the more interesting things that have happened internally at Planet, and that's why I want to share slides. I've got a couple examples, but it's where people will start a project in a hackathon and then maybe work on it at the next hack week, or work on it over the next few hack weeks even. And then ultimately it becomes an open source project, or something that gets shared or gets merged into like their regular workflow or something. So let me share a couple of these that have come through. Actually, one of the more interesting ones, I'll come back to this part in a second. This thing, Chrome and Firefox extensions for Planet Imagery. It's a really relatively simple thing. It's not something you'd think of as being on somebody's, you know, part of their day job sprint cycle, or in their Jira building a browser extension, but it's a fun thing. It's probably the Planet tool I use most, because every time I open my browser, I get a new image. And it came out of a hack week with a bunch of Planeteers working on it. It actually came out of multiple hack weeks. And now it's open sourced on GitHub, but also you can go search for it in Chrome and Firefox extension repos, wherever those may be. So it's great. That was a hack week project. This was also a hack week project, cloud and cloud shadow detection for multi-temporal data. It's a mouthful. Basically what it does is detects clouds and cloud shadows automatically out of PlanetScope data, which is what we call our data that is captured every single day. This was actually, I think, 3 hack weeks. It culminated over a period of 1.5 years. It started with a hack week where people asked, could we do this? And then they figured out, can we do this? And then subsequent hack weeks working on doing it, and then polishing it up and making it more broadly accessible or broadly applicable so that it's actually relevant to other people, and then putting it on GitHub. So that's another hack week thing. Those are just 2 examples that I happen to have in a deck that I was going to show you. This is actually an example of a hack week project, not from Planeteer, so not somebody who works at Planet, but this was at last year's in-person hackathon. Somebody made a API they called Planet Pixel, which is just showing how simple APIs can be. But what it does is pretty neat, and that code block at the top is an example of how you'd use it. It's just pulling 1 pixel of planet imagery for a particular location over a period of time, and then you can plot, for example, they're plotting the brightness of the pixel. And what this person wanted to do in this example was just see when this particular lake froze over, like what date it froze. And so when it changes from dark to light, that's pretty good indication of when it froze. So I thought that was a really cute project. So yeah, that's just a couple that I had examples of, but a lot of hack week projects at Planet start as an idea of like, can we do something? And then people will return to it the next Hack Week a couple months later. Maybe completely different people will pick it up. Maybe at that point, the person who started it is like, yeah, I'm not interested in working on this, but here's everything I learned last Hack Week. And then somebody else will pick it, which is pretty cool. And a minute ago, somebody asked me what the schedule of this virtual hackathon is going to look like in October. And so I happen to have this up on the slide deck. So how it works, if you sign up, like I said, you have to sign up to make sure I have you on my list and send you all the emails. A couple days before the hackathon officially starts, you'll get an email inviting you to join a GitHub repo, basically. We're going to use a GitHub repo to sort of coordinate our remote communication. So you can introduce yourself, get to know other people participating, start brainstorming project ideas together. Normally at the in-person hackathons, we'll have a pitch session where there's a microphone going around the room and everybody has a couple seconds to talk about, here's my idea, anybody want to work on this with me? Since we don't have that opportunity, we're going to actually just do it as GitHub issues and conversations. So you post an issue if you have an idea, people can chime in if they want to participate. That format is actually exactly what we do with our Planet hacks anyway, our company hack week. So we're just copying that for our public stuff. So like that Planet View web extension started as a Git issue. Somebody posted in a repo and other people are like, yeah, I'll help out. So October 15th is when this hackathon officially begins. It's going to kick off in the morning. I think it's going to be like 8 a.m. Pacific time or something around there, TBD. So we'll do some team formation. If people didn't already figure out what they want to work on or where they're going to work ahead of time, they can take some time that morning to figure it out. Then we're just going to open it up to hack time, you know. Like I said, we're going to use Gitter for the chat. So think of it like Slack if you're familiar with that, or Discord. And different project teams will be able to have their private project room. So instead of sitting around a table in physical space together, they can sit in the same chat room. We all also are going to have what we call office hours on Zoom with different Planeteers. At the in-person events, we usually have a bunch of Planeteers from our engineering teams available to like answer questions or help you out, or see if they can figure something out. So we're just going to have Zoom office hours that you can attend and sign up for. And then the second day of the event, similar hack time and office hours, but then at the end of the day, we're going to have the best part of any hackathon, which is the demo party and a virtual social. So everybody will get 3 to 5 minutes to demo what they worked on. I will constantly reiterate, nobody's expected to have a finished project. You can even fudge your demo if you would like to fake it and say, this is what we wanted to do. But just talk about what you did, have fun with it, and then we're all going to hang out on Zoom. Bring your own beverage of choice. Let's see, a couple more questions. Somebody asked how the hackathon was structured. I answered that. Are your APIs typically built using Node Express or in Python? They are in Python. A lot of them use Flask, not Django, even though I love Django. Are regression packages like Cat Boost prohibited from Planet? I actually don't know what that is. I heard that it is for government positions. They might apply there. Yeah, I have no idea what that is, unfortunately, so can't answer that. Do you think it's productive to learn Go, or is it better to work on Python projects to be a more impressive candidate at Planet? That's definitely going to depend on the team you want to work on. However, if I would say go with whichever interests you, because really your passion is what's going to come through. And like nobody knows anything about Planet specific platform anyway. I mean, there's a whole lot of on-the-job learning that happens in every engineering role. So it's really more of a matter of going deep on whatever you're passionate about, and then demonstrating the ability to learn something new once you're hired somewhere. So whether that learn something new is satellite imagery or Planet's tech stack or Golang itself, I think that's probably less relevant than just showing that, like, here's what I can do and here's what I like doing. Hackathon, is it something we can sign up for? Are you describing the in-company? You can sign up, and I did say I was going to give you a link. Let me link that. Gotta find my own link though, because I forgot what it is. All right, there we go. go.planet.com/hack2020. That will take you to the sign up. Yeah, so sorry, I was talking about both our internal and our external hackathons at the same time. It gets confusing at Planet too. Nobody ever knows what I'm talking about. External hackathon is October 15th and 16th. Actually, I should have told you about this and I completely forgot. The reason the external hackathon is October 15th and 16th is because on October 13th and 14th, we're having our annual user conference, which is also free to attend. So if you're interested in hearing even more about Planet Data, sign up for that too. I just posted a link. It's called Explore. Last year it was in person. This year we're going to try it online. We'll see how that goes. All right, let me go check the question list again. Do you use Plotly? You mentioned Flask. I'm not sure what Plotly Dash is, but no, actually, I don't know what that is. So can't answer that. Answer is probably no. What if you just want to see end results? Should we still sign up for it? They're not participating. If you're talking about the hackathon, if you're just interested in the end results and you don't need to see it live necessarily, we're going to do some follow-up blog posts showcasing all of the things that happened at the hack. So just watch our blog, follow us on Twitter or wherever, and we'll post that. Oh yeah, sorry, I just didn't know if Plotly Dash was something specific. I am familiar with Plotly. There are some notebooks that are using Plotly for visualization. I don't use it too much myself just because I'm usually not working with data that I need to visualize in some sort of graphing way, but there are some folks that have done things with it in our notebooks repo. Plotly Dash. Now somebody's linking me to Plotly Dash and I'm going to learn about what this is. Framework for building ML and data science web apps. Interesting. No idea. I don't use it. I don't believe we're using it in any official capacity. There might be people internally who have messed with it. That's cool though. I've never heard of it. Now I'm going to go look about it. Any other questions? I'll zoom through to the end again so I can show you my get in touch with me screen. Actually, look at this screen. This is a good screen. You can learn about the hackathon, sign up for the hackathon. I just happened to be talking to people about our hackathon earlier, so that's why I had these slides.
Well, we're right at time, Sarah.
Oh, cool.
So thank you so much for doing this. I, for one, am jazzed. I'm going to go and sign up for the hackathon.
Awesome. Yay.
I can't wait.
I can't wait to see you all there.
Yeah, I think I'll sign up for the user conference too, so I get a little bit of information before I jump into the hackathon.
I'm excited about attending our user conference in my pajamas. That's going to be pretty great.
Yeah, that's the life in Zoom, right?
Yep.
That's the COVID life.
Yes, indeed.
All right. Well, again, thank you. I really appreciate it. And I'm going to turn off the recording now.